For this video, I'm going to review the scientific method. I'm going to go through the steps of the scientific method when we're doing an experiment, talk about some definitions that has to do with variables, the tenses that should be used when you're writing out scientific method, and then an example. So first, we'll go through the steps. Now, there are some variations of the scientific method. I've tried to combine as many of the terms that are used. It's generally the same sort of steps, but you might see some differences if you do your own research or from past classes. First is the purpose. What is the question that you're trying to answer? So the purpose should always be written in the form of a question. Hypothesis. Once you have your question, you should do a little research, and in class you should be using what we've learned in class to create your hypothesis. Your hypothesis is your educated guess of what your answer to this question would be. And you can start it with, I think blah 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 will happen because, or if this happens, then this happens because. This is the only place in the scientific method where there should be a pronoun, where you use the word I. Everywhere else, it should be past passive. And I'll give you talk a little bit more about that when we get to the example. Materials. Materials is where you would list all the supplies and all of the equipment needed. Everything that you would need to do your experiment, so that anybody could replicate your experiment at any time. And then procedure. Procedure is your step by step. How are we going to carry out the experiment? What are we going to do step by step by step? Again, so that someone else could duplicate your experiment. The next section is the results or the observations. This is where you write down and you document what happens. What do you see? What do you hear? And you write down as much data as possible. You could, it could be timed. You're watching the time and you're showing what's happening over time. It could be, or it could just be your basic observations over a period of time. Your conclusion. Was our hypothesis correct? This is where you look at your results and your observations and you go back to your hypothesis and you evaluate, was my hypothesis correct in answering my question? This one here, application and communication, is a strong focus this year, where you need to communicate your understanding or your learning in the experiment and how it applies to the regular everyday society. How can you apply, the melting of an ice cube to your understanding of heat in the world? Here's some terms that have to do with variables. So there's an independent variable. When we do an experiment, we should only change one thing or variable. Because if you change more than one, you don't know if your dependent variable or your outcome, which variable it's based on. So only change one variable. So the one thing that you're changing, it's called the independent variable. The dependent variable is the outcome that's caused by changing the independent variable. So we know that this happened because we did this. And again, another reason why you should only have one variable that you change. Your control should be something that does not receive the independent variable. So a control group where there's nothing changed for that group. So you have something to compare. And then a constant. This is something that doesn't change from experiment to experiment to experiment. So if you're trying to answer one certain question and you change one variable, and then in the next experiment you replicate the entire experiment except you change one other variable, that is what I mean by constant. So most of the things in the experiment stay the same except for one thing that you change. So here's an example of our scientific method. So I've written out my purpose, and my question is, what happens to an ice cube when it is heated? That should be a question mark. My hypothesis. If the particles in a solid are heated, then their energy of attraction and kinetic energy will increase, causing a change of state. You can see that I've used my understanding of states of matter and the particle theory to make my hypothesis. Materials. I need one hot plate and I need one ice cube. Procedure. Plugged in hot plate, allowed plate to warm, placed ice cube on hot plate, waited 3 minutes. This is where that passive past tense comes into play. Notice it's plugged. I did it in the past. It shouldn't be in present tense where you're doing the experiment right now, because you're not. You've already done the experiment and you're handing in your scientific method, you're handing in your results. So it's plugged in hot plate, allowed, placed, waited. These are what you did in the past. That's that past passive. There are no pronouns. It doesn't say I plugged in the hot plate, I allowed the plate to warm. Past tense, passive. Results, observations. Cracking sound at 45 seconds, water around the bottom of the cube. At 1 minute, 35 seconds, cube has decreased in height. 2 minutes, 11 seconds, liquid bubbling. 2 minutes, 59 seconds, no cube visible, only water. Those are my results. Now, I could put these in a chart. I could make a graph. There's lots of different ways I can display my results and my observations. My conclusion. My hypothesis was correct. So I go back and I check to see if my hypothesis is correct, and I was right. There is a change of state from a solid to a liquid. Your homework is to come up with an application. You need to tell me how I can use this piece of information and the information I've gained from this experiment in the real world.